This lesson looks at graph theory's definitions. A graph is a diagram that summarizes the information in a network. A graph consists of a set of points called vertices or nodes that are joined by a set of lines called edges. Each edge joins two vertices. A loop is an edge that joins a vertex to itself. Two or more edges that connect the same vertices are called multiple edges. The degree of a vertex is the number of edges attached to the vertex. The degree of a vertex is denoted DEG bracket capital V. For example, in the graph, the degree of A is 1, 2, 3, 4. The degree of B is 2. A loop actually contributes 2 degrees to a vertex because a loop is attached to its vertex at both ends, so the degree of C is 1, 2, 3, 4. A loop, however, contributes only one edge to the graph. In any graph, the sum of the degrees of the vertices is equal to twice the number of edges. That makes sense because at the end of each edge is 2 vertices. You'll find your work at exercise 9b. To help you get started, let's have a look at one of the question parts from question 1. Here's a question that shows a network and we have 1, 2, 3, 4 vertices. The graph has 1, 2, 3, 4, 5, 6, 7 edges. The graph has only one loop. The degree of B is 1, 2, 3, 4, 5, 6. Remembering a loop contributes 2 to the degrees. The degree of D is 1, 2. In fact, let's look at the degrees of the other vertices. The degree of A is 3. And the degree of C is also 3. The graph has how many odd vertices? Well, we've got 2 even ones there and we've got 2 odd ones there. So the graph has 2 even vertices. From your early practice, you would realize because this network has 2 odd vertices only, that you can actually traverse it covering every edge only once. That's what Euler found with the Konigsberg bridge problem. But you have to start at one of the odd vertices and finish at the other. Pause the video and have a go at it yourself. Okay, I'll give it a go. I'll start at one of the odd vertices here. Notice you can go through vertices more than once, but each edge was only crossed once, and I ended at the opposite odd vertex. The game of sprouts is worth having a go at, so if you didn't see the rules already, pause this screen and have a look at the rules for the game. The direct link to more information about the game of sprouts is shown here. That'll save you going through the Cambridge website. Here you can see a sample game of the game of sprouts. Pause the screen and have a look at the sample game to help you play with another person.